Okay, today we're going to talk about horizontal and vertical lines. And before we start this video, I wanted to remind you that as you're going through the video, you want to make sure you're not just copying down what's on the screen, but you're really listening and involving yourself in the material. You want to make sure you're actively learning the material, not just copying down what you see. Copying down is great to have those references in your spiral notebook, but unless you're really thinking about the material and going through it in your head, working through it, thinking through the problems with me as we go, this is going to become very difficult for you to continue with the flipping the classroom video. So make sure that you're involving yourself with the video to make sure you're learning the content. All right, horizontal and vertical lines, what you're going to need is your spiral notebook, and also if you have graph paper of your own, you might want to grab that too. It's an option. It certainly is not required. You will be drawing some coordinate planes, and you can use the graphing paper to help you, but you don't have to have it. So go ahead and pause the video and make sure you have all those materials. Okay, the vocabulary that you're going to need to know is the words horizontal and vertical. Horizontal is going to be a line that moves from side to side. Do you see the word horizon in there? If you look out over the horizon, you'll see a line separating the land from the sky. Horizon, side to side. Horizontal means side to side. Vertical would be straight up and down. Vertical, moving straight up and down. All right? This first example, you don't need to copy down. You just need to observe and learn through how these pieces go together. In the last video about linear equations, we talked about function tables, ordered pairs, and graphing. Same thing here. As long as you have one of those three key components, you should be able to figure out the other two. Here we're going to be starting with the graph and working our way backwards and doing the function table and the ordered pairs after. Take a look at this graph here, this coordinate plane. Do you see the vertical line? I've chosen a few points on the vertical line, and I've written a couple of the ordered pairs there. There are certainly many, many more. This line extends both upward and downward in infinity, and there's an infinite number of points on that line as well. I've just selected 3 particular points. Notice I've already labeled the ordered pairs, and I can choose another one. I have it marked here in purple. This would be 2, -4. Remember, you're graphing here. All right, so once you have your ordered pairs from the line, you can take those ordered pairs and write them in a function table. So take a look at my function table here. I've taken 2, 2, and put it in the function table, 2, 0, and 2, -3. Now if I add my additional purple point here, I've got 2, -4. So the 2 is the x value, and the y value is -4. All right, now when you're looking at a function table and trying to get the equation, you're looking for a pattern. The equation is the pattern in the function table. Now if you look side to side and see if you can find a pattern, you'll notice there's no way to add the same amount each and every time to get the y value. There's no way to multiply, subtract, or divide. There is no pattern from the x value to the y value. No consistent pattern there. However, there is a pattern going down the x column. All of the x values are the same. They are all 2. So that we can use that pattern to make our equation. So all the x values are 2, so your equation is x equals 2. Now there is additional way of writing that. Some people get really concerned if they don't have the x and the y value included in their equation. You can write it that way. X equals 2 plus 0 y's. If you plugged in any of these x values into this equation and solved, you could see how you would get all of these y values. For instance, 2 plus 0 times y. If you go through and solve that, you will see that you would get -4 for your y value. So let's go ahead and take a look at this example. Go ahead and write this example there in your notes. You can pause the video if you need to. Copy this coordinate plane. You can use graph paper. And if you're doing it in your spiral notebook, don't take a long time to make nice straight lines and even tick marks and many, many, many tick marks. Just a nice little quick coordinate plane, as straight as you can get it. As you can see mine here, I've got a little extra here. Just draw a little quick little plane and put your vertical line here and label those points. Go ahead and pause the video now and take care of that. All right, once you have that done, we're going to go ahead and write a function table. You're going to take the 3 ordered pairs from that line and write them in the function table. So in your spiral notebook, go ahead and draw yourself a function table and put each of those ordered pairs into that function table. We've got -2, 3. So -2, 3. You've got -2, 1. And you've got -2, -3. Now you want to look for a pattern in order for you to come up with your equation. If you look from side to side, although we're starting with -2 every time, is there a pattern? Is there a way that you can multiply, add, subtract, or multiply, or divide to get these y coordinates? I don't think so. But there is a pattern going down the x column. Down the x column, there are all -2's. So the equation for this is x equals -2. Each and every time you look at a point on this line, the x coordinate will always be -2. All right, take a look at this coordinate plane. You do not need to copy this. This is simply for you to look at. Take a look at this coordinate plane. I have a horizontal line drawn now, a horizontal line, and I've chosen several points on that line. From there, I've taken those ordered pairs and I've written them in a function table. So I've got -3, 1 is here. I've got positive 1, 1, positive 2, 1, 0, 1 are all points from this plane, and from this line. I also have a purple point here, -2, 1. So -2 is my x value, and 1 is my y value. There is no pattern side to side, but there is a pattern going down the y column. All the y coordinates are 1. That's your equation. Always look for that pattern. Pattern is y is always 1. Now, if you'd like to include the x value, I think it adds a little bit of complexity to the equation that you really don't need. But if you feel more comfortable, you can certainly add 1 plus 0x. Anything times 0 would give you 0. All right, here's one I do want you to copy down. Go ahead and draw this coordinate plane either on your graph paper or on your spiral notebook and label this horizontal line with these points. Go ahead and pause the video to make sure that you can get that done. Okay, now on this line, I'm going to take each of these ordered pairs and I'm going to write them in a function table. Go ahead and draw a function table in your spiral notebook, and we're going to go ahead and take these ordered pairs and record them on that function table. So we've got -3, -3. Excuse me. -1, -3. 2, -3. Take a look and see. There's no pattern going side to side, but there is pattern going down. Do you see the pattern? Go ahead and write the equation that you think matches that. Great. Did you have y equals -3? Always look for that pattern. Oops. All right. These are 2 examples for you to try. I want you to take a look. We've got example 3 and 4. You've got x equals 2 and y equals -3. I'm going to have you work in a different order this time. I've given you the equation. You need to do the function table and the graph. Again, the same thing for number 4. Do the function table and the graph that goes with it. Go ahead and pause the video and then come on back and we'll go over your answers. Okay, so for this number 3, x equals 2. So in my x column, I'm going to put all 2's. In my y column, I get to choose whichever values I like. Now, I know I have a very small coordinate plane, so I don't want to go too crazy and pick 128. It's not going to fit. I'm going to pick smaller numbers, numbers that will fit on my plane. So I'm going to choose 0, -1, and 2. All right. Excuse me. Let's go ahead and graph. I've got my ordered pairs, 2, 0, 2, -1, and 2, 2. And I'm going to graph. And remember, you could have chosen completely different numbers. Just because you don't have the ones I have does not mean what you have is wrong. I've chosen these particular numbers. You could have chosen something else. However, no matter whether you chose my numbers or your own, your line should be located in the exact same spot as mine. You should have a vertical line on the 2. You know a trick that can help you figure out whether it's going to be vertical or horizontal? Look at the letter X. X equals 2, right? Look at the X. Do you see the V? V for vertical. All right, take a look at number 4. Y equals -3. That means all my Y numbers are going to be -3. My X values, I get to pick whichever ones I want. All right, here are my ordered pairs. And I'm going to graph them. Again, you could have chosen much different numbers. That does not matter as much because this line extends forever and ever and ever. And your line should be horizontal and it should be lined up with the -3 on the y-axis. You want to know a trick about the y's? Y equals -3 was our equation. Take a look at that y. If you flip it upside down, does it kind of look like an H? Kind of. H for horizontal. Just little tricks that might help you remember when the time comes to determine whether or not it's going to be a horizontal or a vertical line. Remember, all 3 pieces go together: an equation, a function table, and a graph. And no matter which one you have, you should be able to figure out the other 2. We'll do some more practice problems with horizontal and vertical in class soon. See you there.